Hello mathematicians, here are your notes, section 10.7 and 10.8. Topic of the day is volume. By the time I'm done here, you should know what volume is, what it measures, and you should be familiar with 5 new formulas and how we came about figuring these formulas out. Alright, the definition of volume. Volume involves filling containers with cubes. We're filling up containers with cubes. Filling. With what? With cubes. Alright, say that to yourself. What is volume? Yep, filling with cubes. Alright, earlier in this unit, Unit 9, I noticed we're not too familiar with our units of measure. So I'm going to briefly go over that. If you're trying to measure any of these, length, width, height, perimeter, circumference, radius, diameter, slant height, distance, then you would just use plain old units of measure. Centimeters, miles, inches, yards. Just one straight unit. Now we don't know if you don't know what the unit is, you use the word unit, but otherwise you'd use, like I said, centimeters, inches, yards, miles, feet. If, on the other hand, you're measuring area, remember area is to cover with squares. Then you're going to use a square unit. Makes sense. You're covering with squares, and they're in the shape of a square, so they're called square units. That could be a square centimeter, a square mile, a square inch, versus just a regular inch. Inches are straight. A square inch is in the shape of a square. Today, however, we're studying volume, which is to fill with cubes. And now they're three-dimensional. So this would be an example of a cubic unit. It's a cube. It could be a cubic inch. A yard cubed. This could be a cubic mile. So plain old, this would be like a plain centimeter, a square centimeter, and a cubic centimeter. Alright, so today, it's units cubed. Alright, how do I find volume? You find volume by using the correct formula. So make sure you use the correct formula. And you follow the formula. You can't change the formulas. They are established rules. They are recipes that must be followed. Where do these formulas come from? What's the idea behind the formulas? Well, it's really simple. Since we're filling containers, you fill the bottom layer first. Fill the bottom layer first. Then you just keep repeating that layer by layer by layer by layer. So then you multiply by the number of layers. You multiply by the number of layers. Alright, let's keep going. The first shape, rectangular prism. Okay, we're first going to fill up the bottom layer. So we're going to fill up the bottom layer, which is a rectangle. So volume is filling. We're going to fill up the bottom layer. Well, how many cubes would fit right sitting here? You would just go base times height, or length times width. Base times height, which is also length times width. Then you would continue layering and layering and layering and layering, getting taller and taller and taller and taller. How tall would it get? Well, then you'd use capital H. Capital H tells you how many layers. So then you'd multiply by capital H. And that's it. You filled up the bottom first, and then you multiply by the layers. Now some of you have learned instead of base times height, some of you have learned it length times width times height. Either way is good. Alright, next container is a triangular prism. It uses the same theory. Fill up the bottom first. Now this time the bottom is a triangle. Oh, so use the triangle formula. Volume equals base times height divided by 2. So that's the bottom layer. Now notice we're using small h. I show you it up here. Small h is right here, how tall the triangle is. Just how tall the triangle is. And this triangle here on top is the same as the one on the bottom. So if I fill up the bottom, I can measure using the top or the bottom. And then I just layer it and layer it and layer it and layer it. So I'll fill up this triangle and then next triangle, next triangle, next triangle, next triangle, next. How many layers would it be? Well, that's capital H. Capital H tells you how many layers. So there's your formula. Again, I filled up the bottom first, and this time the bottom is a triangle. And then capital H tells you how many layers. Capital H is how tall the container is. Alright, last one. The square pyramid. Same idea. Volume equals, fill up that bottom layer. The bottom layer in this case is a square. So you're going to go base times height. You could also think of it as length times width. Now the layers keep getting smaller and smaller and smaller. So there would be H layers, but that would be if I just kept filling it exactly the same. So capital H tells you how many layers if they're all the same, but it keeps getting smaller and smaller. And to tell you the truth, what you really do is you take this formula up here and just divide it by 3. So it's the same formula, but it's getting skinnier and skinnier and skinnier, and you divide by 3. And the reason is because actually 3 of these pyramids would fit into a prism. 3 pyramids would fit into one prism. So that's why I'm taking a third. I'm taking the prism and dividing it by 3. Alright, just a few more. Alright, here we go. A cylinder. Go with your same thought process. Fill up the bottom layer first. And what shape is the bottom? If I fill up the bottom, it's a circle. So that's pi times the radius squared. Radius squared means r times itself. It does not mean r times 2. It does not mean r times 2. Pi times the radius squared would fill up the bottom layer, and then you'd keep adding layers and layers and layers and layers and layers. How many layers would it take? H. So you're going to multiply by H. So there it is, the bottom layer times the layers. Notice we're always multiplying by capital H, and you need to know that capital H is how tall the container is. Alright, let's see if you have a guess about the cone. Cones are similar to, or look a lot like cylinders. So a cone is almost like a cylinder. So you're going to fill up the bottom and layer it, but that would be too many if you just kept layering circle upon circle upon circle. It gets thinner and thinner. Ah, I bet you divide by 3. Yep. Volume equals, fill up the bottom, multiply it by the layers, but since it keeps getting skinnier, we got to divide it. And we're going to divide it by 3. So it's the same formula as this one, except we divided by 3. And the reason we divided by 3 is because, believe it or not, 3 cones will fit into one cylinder. All right, I hope this is helpful. We're going to next learn how to actually use the formulas. Good luck.